In the middle of World War II, the race for power and survival was ruthless. Tanks were longer just armored vehicles. They were the beating heart of modern warfare, and the Allies knew they needed something extraordinary to dominate the battlefield. Enter the Ford GAA engine, a monstrous 1,100 cubic inch V8 that seemed almost too powerful, too ambitious, and too dangerous for its time. But this wasn't just another engine. It was a mechanical revelation born out of necessity, obsession, and the relentless American drive to out-engineer the enemy. Ford Motor Company had built its empire on mass production and automotive innovation, but the GAA was unlike anything in their civilian lineup. The U.S. Army needed a high-performance, reliable engine capable of powering heavy tanks like the M4A3 Sherman. They demanded endurance, raw torque, and versatility, but the timelines were brutal. There was no room for error. Most engineers would have balked at the challenge, but Ford's team thrived under pressure, seeing opportunity where others saw impossibility. The GAA's design philosophy was radical. Instead of modifying an existing automotive engine, Ford engineers treated this as a clean slate, crafting a purpose-built tank engine. A T-1,100 cubic inches, it was gargantuan, almost unheard of in the automotive world, yet necessary to propel heavily armored tanks at speed across unpredictable terrain. Every inch of the engine was optimized for war. Oversized pistons, high-strength steel blocks, and dual overhead valves designed for maximum airflow and efficiency. It was a mechanical juggernaut, precise yet brutal, elegant yet unforgiving. What made the GAA truly remarkable was its blend of American industrial practicality and sheer engineering audacity. Ford engineers leveraged mass production techniques while integrating high-performance military specifications, a balancing act few could manage. The engine had to be powerful enough to move a 33-ton Sherman at 30 miles per hour, yet durable enough to survive the rigors of combat. Every failure could mean disaster for soldiers on the front lines, yet the GAA consistently delivered, proving that meticulous design and relentless testing could defy conventional limits. The circumstances of its creation were also telling. Wartime secrecy meant that many details were classified. Even within Ford, only a handful of engineers understood the full scope of the GAA's potential. Rumors of its power circulated among tank crews, engineers, and rival manufacturers, feeding a mystique that would only grow over decades. Some called it a beast engine. Others whispered that it was too ambitious to ever be practical. But the engine proved them wrong time and time again. The GAA wasn't just about brute force. It was about precision, timing, and adaptability. Engineers had to calculate thermal expansion, gear ratios, and fuel consumption to near perfection, all while dealing with the enormous scale of the engine. Unlike civilian engines, there was no tolerance for minor errors. Any miscalculation could destroy an engine block or immobilize a tank in the middle of a battlefield. It was high-stakes engineering at its most intense, and the misfit visionaries at Ford relished the challenge. By the time the first GAA engines rolled off the production line, they represented more than military machinery. They were symbols of ingenuity, audacity, and American industrial might. This was an engine designed to intimidate, to endure, and to dominate, and its story would soon reveal secrets, controversies, and feats that no ordinary engine could ever achieve. The stage was set. The Ford GAA was ready to prove that sometimes the most shocking truths lie not in myths or legends, but in raw, unbridled engineering power. Engineering marvel, the Ford GAA engine. The Ford GAA engine was not just another wartime machine. It was an audacious leap of engineering imagination, the kind of creation that happens only when necessity, genius, and courage collide. Built during one of the darkest periods of the 20th century, it represented far more than pistons, valves, and horsepower. It was a declaration that American industry could rise to challenges no one else dared face. In the crucible of World War II, where every decision carried the weight of victory or defeat, the GAA emerged as a statement. America would not just compete on the battlefield, it would dominate through engineering mastery. At its heart, the GAA was an 1,100 cubic inch V8, colossal by any measure, even today. To put that in perspective, most passenger car engines of the 1940s hovered around 200 to 300 cubic inches. The GAA dwarfed them all, a power plant so massive that it seemed almost too big to be real. Yet every inch of it was meticulously calculated. Its size wasn't about extravagance. It was about necessity. Sherman tanks weighed more than 30 tons and needed a source of power that could push them across mud, snow, deserts, and bombed-out European cities without faltering. Where smaller engines would choke or overheat, the GAA delivered relentless power and stamina. Ford's engineers didn't stumble into this achievement. They began with knowledge gain from the aviation world, adapting concepts originally meant for aircraft engines and transforming them into a ground-based monster. The dual overhead camshaft design, a rarity in the 1940s, gave the engine extraordinary airflow and combustion efficiency. In simpler terms, the GAA could breathe better, burn fuel more effectively, and sustain higher performance without tearing itself apart. In an era where many military engines were still using outdated flathead or pushrod systems, this was a glimpse into the future. Every component of the GAA was crafted with endurance in mind. Pistons were oversized and forged from high-strength alloys to withstand brutal heat and pressure. The crankshaft, the backbone of any engine, was engineered like a work of art designed to handle torque levels that would shatter conventional designs. Bearings, gaskets, and cylinder heads were all subjected to relentless stress testing. The engine block itself was massive yet carefully balanced, ensuring it could fit within the M4A3 Sherman's chassis without upsetting weight distribution. Nothing was left to chance because in battle, a failure wasn't just an inconvenience, it could mean death for the crew. One of the most remarkable aspects of the GAA was its blend of brute force with surprising finesse, producing nearly 500 horsepower at a time when many tanks struggled to achieve. Half that, it allowed the Sherman to move with a speed and agility its enemies did not. Expect torque delivery was immense, giving the tank the raw muscle to climb hills, plow through rubble, and push forward under conditions that would cripple lesser machines. But it wasn't just raw numbers, it was how the engine delivered them. Thanks to its advanced valve design and balanced internals, the GAA ran smoother and responded more quickly than rivals. For tank crews, that meant not only more power, but also more control. Ford's mass production expertise gave the GAA another edge. Henry Ford's company was already famous for its assembly line efficiency, but now that efficiency was combined with military precision. Tolerances were much tighter than anything found in civilian cars. Yet, Ford managed to produce these massive engines at scale without sacrificing quality. Each one could be assembled, tested, and shipped quickly, ensuring the U.S. Army never had to wait long for replacements or reinforcements. This marriage of industrial speed and engineering accuracy was revolutionary, and it underscored America's unique ability to turn vision into reality on a global scale. Still, the GAA demanded respect. Its immense size and complexity meant that improper handling could lead to catastrophic problems. Tank crews had to be trained not just in operating their vehicles, but in understanding the quirks of the engine itself, its cooling requirements, its fuel sensitivity, and its maintenance routines. Engineers were constantly monitoring battlefield feedback, refining details, and ensuring the GAA lived up to its promise. It wasn't an engine that forgave mistakes, but for those who mastered it, it became a weapon as formidable as the Sherman's gun. Looking back, what makes the Ford GAA stand out is not simply its raw power, but the philosophy behind it. This was not an engine built to cut corners or save costs. It was an engine built with the understanding that survival on the battlefield demanded perfection. Every decision, from the choice of materials to the configuration of valves, was driven by one principle: failure was not an option. That uncompromising ethos made the GAA more than a machine. It made it a symbol of what could be achieved when engineers refused to settle for good enough. Today, historians and engineers alike still marvel at the GAA. Few wartime engines have ever managed to combine such staggering power with reliability and mass production feasibility. In many ways, it redefined what was possible for tank power plants, setting a standard that influenced military and civilian engineering for decades to come. It remains a testament to the brilliance and audacity of Ford's misfit team of engineers who dared to imagine something bigger, bolder, and better than anyone thought possible. The Ford GAA wasn't just an engine, it was a war-winning instrument, a technological marvel, and a lasting reminder that, in the face of overwhelming odds, innovation can tilt the balance of history. Engineering precision under pressure. Unlike many wartime engines, which were hurried into production with compromises, the GAA refused shortcuts. Ford's engineers understood that tanks didn't have the luxury of pulling over for repairs. Every component had to be strong enough to survive combat, where a single failure could cost lives. Pistons were enormous, forged from high-strength alloys designed to withstand relentless pressure and blistering heat. The crankshaft, perhaps the single most stressed part of any engine, was a masterpiece of balance and durability, capable of handling torque levels that would have destroyed ordinary designs. Bearings, gaskets, and cylinder heads weren't just manufactured, they were tested to extremes. Engineers put them through stress scenarios few civilian engines would ever face: prolonged heat, constant vibration, heavy loads, and sudden bursts of acceleration. The block itself, though massive, was engineered with surprising care for weight distribution, so that it could fit neatly into the M4A3 Sherman's chassis without throwing off balance. Every design choice echoed the same principle. This was not a machine built to be pretty, but to endure. Dual overhead valves, ahead of its time. One of the GAA's most remarkable features was its dual overhead camshaft valve system. In the early 1940s, most engines, even for military use, relied on simpler, pushrod-driven designs. Ford's choice to employ dual overhead cams was daring, almost experimental, but the payoff was enormous. This setup allowed unprecedented airflow, combustion, efficiency, and responsiveness. What it meant in practice was that the GAA wasn't just powerful, it was smooth. Tank cruise. Notice that it accelerated steadily, climbed inclines without hesitation, and maintained performance in grueling conditions where other engines might choke. It was a rare marriage of brute force and mechanical grace, a war machine that performed almost like a precision-tuned sports car, but on a battlefield. Ford's assembly line meets the battlefield. Another crucial factor in the GAA's success was Ford's unmatched expertise in mass production. Long before the war, Henry Ford had revolutionized the automobile industry with the moving assembly line, a system that transformed car building from a slow, craft-based process into an efficient, affordable miracle of industrialization. By the 1940s, that philosophy had matured into something greater than a business model. It was a way of thinking. And when war called, Ford redirected that same philosophy to military manufacturing, proving that innovation in process could be as vital as innovation in design. The challenge was monumental. Producing an advanced, high-performance engine on a massive scale might have seemed impossible. Aircraft-style engineering, with its tight tolerances and demanding quality standards, was usually confined to small batch production in specialized workshops. Scaling that up to thousands of engines for Sherman tanks seemed like a contradiction. Mass production, by its very nature, allowed for minor imperfections. The battlefield, by its very nature, did not forgive them, but Ford made the impossible look routine. The GAA was not just another product rolling off a conveyor belt. It was an 1,100 cubic inch beast, larger, heavier, and far more complex than any civilian engine Ford had ever built. Yet the company treated it with the same discipline it once applied to the Model T. Each workstation was designed with precision tasks in mind, and each worker was trained not just to assemble but to understand. The difference lay in the expectations. Instead of producing a car that had to last a decade on city streets, they were building a machine that had to survive months of relentless war without faltering. Tolerances were tighter than anything used in civilian vehicles, sometimes measured in thousandths of an inch. That meant pistons had to fit perfectly within cylinders, bearings had to align seamlessly, and crankshafts had to spin with flawless balance. In ordinary auto plants, small deviations might pass unnoticed. In the GAA program, they were unacceptable. Assembly line workers, once accustomed to handling parts with broad allowances, now had to think like aircraft technicians. A mistake wasn't just a defective car. It was a failed tank, a stranded crew, and potentially a lost battle. Ford responded by transforming its workforce. Men and women who had once been ordinary factory hands became specialists. Training programs drilled them in precision, discipline, and accountability. They were told repeatedly that their work mattered, that every bolt tightened correctly and every seal fitted properly was part of the larger war effort. In many cases, workers signed off on the engines they built, putting their reputations on the line. Pride and patriotism became as much a part of the assembly line as steel and oil. The results were astonishing. Thousands of GAA engines rolled off the line with consistent reliability, each one meeting the exacting standards demanded by the U.S. military. Quality, inspectors tested and retested, but the engines rarely failed scrutiny. Ford had proven something extraordinary. Industrial scale and surgical precision were not mutually exclusive. For decades, skeptics had believed that one had to choose either build quickly and cheaply or build carefully and perfectly. With the GAA, Ford demonstrated that with enough innovation and discipline, both goals could be achieved simultaneously. This achievement had ripple effects far beyond the tank itself. The sheer pace of production meant that Sherman tanks could be fielded in staggering numbers, giving the Allies not just quality but also overwhelming quantity, where Germany relied on small runs of technically brilliant but difficult to produce machines. America flooded the battlefield with reliable, powerful vehicles. The GAA was a direct embodiment of this strategy, an engine advanced enough to compete head-to-head, yet simple and consistent enough to be mass-produced. It wasn't just machinery being built on those lines, it was confidence. Each completed GAA was a silent promise to the soldiers waiting overseas that their tanks would run, that their engines would not fail them when it mattered most. Workers in Detroit, Dearborn, and beyond knew this, and they carried that burden with pride. The assembly line became a bridge between home and front line, between industrial might and battlefield survival. Even decades later, historians point to Ford's GAA program as a turning point in wartime production. It showed that America's true weapon wasn't just its soldiers or generals, but its factories. The ability to scale complex engineering into repeatable, reliable production was as decisive as any strategy or tactic. Ford's marriage of mass production and precision engineering not only powered tanks, but also redefined what industrial mobilization could achieve. Ultimately, the story of Ford's assembly line meeting the battlefield is about more than machines. It is about vision, the belief that ordinary people, guided by discipline and process, could accomplish extraordinary things. It is about the transformation of industry into a weapon as potent as any gun or cannon. And it is about a promise kept that American ingenuity would never fail those who needed it most. A machine that demanded respect. For all its brilliance, the GAA was not a forgiving machine. With nearly 500 horsepower on tap, a staggering figure at a time when most tanks struggled with half that output. It demanded skilled handling. Tank crews had to be trained not only in driving, but in understanding the engine's needs. Proper cooling, careful fueling, and diligent maintenance. Improper installation or care could spell disaster. Engineers warned crews about its quirks, from its appetite for clean oil to the importance of precise timing adjustments. It wasn't an engine you could neglect. It demanded respect, much like a thoroughbred racehorse. And those who respected it found themselves in command of one of the most formidable power plants of the war. Numbers that changed the game. On paper, the GAA's performance was astonishing. Nearly 500 horsepower gave the Sherman an edge it had sorely lacked in earlier versions. Torque was immense, allowing the tank to muscle its way across rough terrain, climb hills, and push through obstacles that would have stalled lesser vehicles. More importantly, this power didn't come at the cost of reliability. The GAA was designed to run for months under combat conditions, enduring extreme cold, scorching heat, and punishing battlefields. Where other engines might seize, crack, or falter, the GAA kept running. For tank crews, this reliability was more than convenience. It was survival, a paradigm shift in military engineering. What truly set the GAA apart wasn't just its size, power, or even its reliability. It was the philosophy it embodied. Before the GAA, many military engines were designed reactively. Good enough to work, good enough to get by. Ford rejected good enough. The GAA set a new expectation, proving that an engine could be both mass-produced and engineered to near perfection. This was a paradigm shift. It redefined what a tank engine could and should be. Even decades later, engineers and historians look back at the GAA with awe, noting how few engines, civilian or military, could rival its balance of strength, innovation, and practicality. The legend lives on. Today, the GAA is remembered not just as a tank engine, but as a legend of mechanical audacity. Restorers and collectors who encounter it marvel at its design, appreciating the way every component reflects a wartime demand for both excellence and urgency. To see one up close is to glimpse the mindset of Ford's misfit engineersmen who believed that, even in war, precision and artistry matter. The GAA's legacy lies not only in the tanks it powered, but in what it symbolized: the refusal to compromise, the belief that engineering could be both bold and reliable, and the proof that visionaries working under immense pressure could create something truly extraordinary. In the end, the GAA was more than a mechanical marvel. It was a war-winning instrument, a machine that helped shape the outcome of a global conflict. And it stands today as a reminder that sometimes the most audacious designs are the ones that last the longest, not because they were easy to build, but because they dare to aim higher than anyone thought possible. Power on the battlefield. The true measure of any engine lies not in specifications or tests, but in its performance under fire. For the Ford GAA, the battlefield was both proving ground and stage, and it proved itself spectacularly. Mounted in the M4A3 Sherman, and later in other armored vehicles, this 1,100 cubic inch V8 transformed the Sherman from a capable tank into a war-winning machine. Its raw torque allowed the heavy 33-ton chassis to surge forward with unexpected agility, climbing steep inclines, traversing rough terrain, and pushing through mud or rubble where lesser engines would falter. Tank crews quickly learned that the GAA was no ordinary engine. Unlike civilian power plants, it demanded respect and understanding. Its immense power could be both a blessing and a challenge. Shermans were sometimes criticized for being underpowered compared to German counterparts. With the GAA, the balance shifted. The engine's torque and responsiveness allowed crews to execute maneuvers that were previously impossible, and the reliability reduced downtime that could prove fatal. In essence, the GAA not only powered tanks, it empowered their crews, enhancing confidence and effectiveness in combat. Beyond raw performance, the engine carried a psychological weight. Its rumble and sheer size were intimidating to enemy forces, while inspiring awe among Allied soldiers. It symbolized technological ingenuity, industrial might, and the audacity to build something that seemed almost excessive in its ambition. The GAA embodied the idea that power, precision, and engineering could decisively influence the outcome of battle. It was an engine that didn't just drive tanks, it drove victory. The battlefield history of the Ford GAA cements its status as more than a mechanical marvel. It proved that a visionary, ambitious, and precisely engineered machine could endure the chaos of war, outperform expectations, and save lives. For those who witnessed its power firsthand, the engine was a legend, a living testament to what audacious engineering could achieve when combined with courage, necessity, and relentless pursuit of perfection, controversy, and secrets. Even a marvel as formidable as the Ford GAA could not escape whispers, rumors, and controversy. While soldiers praised its power and reliability, the engine carried secrets that remained hidden from the public and even most Allied forces. Wartime secrecy was intense. Technical specifications, production methods, and engineering breakthroughs were classified to prevent enemy acquisition. Only a select few engineers, commanders, and mechanics truly understood the scope of the GAA's capabilities. One source of controversy was the engine's sheer ambition. At 1,100 cubic inches and nearly 500 horsepower, it was overkill by conventional standards of the era. Critics questioned whether it was practical, sustainable, or even safe to deploy such a massive power plant. Some argued that the logistical strain of fueling, maintaining, and transporting these engines outweighed their benefits. Yet, history proved otherwise. The GAA consistently performed beyond expectations, demonstrating that audacious engineering could overcome practical concerns. Secrecy fueled myths and speculation. Rumors spread that the engine could push tanks at impossible speeds or survive impossible conditions, exaggerating its already impressive capabilities. Stories circulated of tanks outrunning artillery or climbing impossibly steep hills, attributing feats to magical engineering. While dramatized, these tales captured the imagination of both Allied troops and post-war enthusiasts, elevating the GAA into legend. Internal controversies also emerged within Ford and the military. The engine's complexity meant that production demanded extraordinary precision, often pushing factory workers and engineers to their limits. Mistakes could be catastrophic. A misaligned crankshaft or faulty piston could destroy an engine before deployment. Some within Ford questioned whether such exacting standards were feasible under wartime pressures. Military officials, meanwhile, worried about the learning curve for crews and mechanics in the field. The tension between innovation, secrecy, and practicality created a delicate balancing act that few could navigate successfully. Even decades later, the GAA's secrets continued to intrigue historians and collectors. Many surviving engines are housed in museums or private collections where enthusiasts marvel at the engineering sophistication hidden within its massive V8 block. Detailed schematics, maintenance manuals, and factory notes reveal that every decision from valve timing to metallurgy was calculated to maximize performance and durability. Yet, some details remain lost to time, preserved only in anecdotes from those who built or operated these mechanical beasts. The GAA's controversy also extends to its reputation in automotive and military history. While some debate whether it was over-engineered or overly ambitious, few dispute its effectiveness. It represents a moment when audacity, necessity, and precise engineering collided. Its secrets, myths, and controversies only serve to enhance its mystique, transforming a simple war engine into a story of obsession, ambition, and brilliance that continues to captivate enthusiasts today. Ultimately, the Ford GAA proves that even the most impressive engineering feats are not free from debate or doubt. Its size, power, and complexity shocked contemporaries, while secrecy and wartime politics fueled rumors that linger to this day. Yet these controversies do not diminish the engine. They underscore its audacity, its genius, and the boldness of the misfit engineers who dared to build a war machine unlike anything the world had ever seen. If you enjoyed this incredible story, don't forget to hit the like button, share it with your friends, and subscribe to the channel for more epic automotive adventures. Your support keeps these stories alive.